theory is mainly mathematics. The standard approach is to model the evolution over time of the number of customers in the system as a random process. The mean performance of the system is then obtained from an analysis of the steady-state regime of this random process. The first step of this modeling is to characterize the system. The system has different characteristics. First of all, we have to characterize the arrival process of customers. In other words, the way customers arrive in the system. The customer arrival process is often modeled as a Poisson process. Then, we have to characterize the service duration, meaning the time which is required to serve each client. Note that the service duration is often modeled as an exponential law. It's also necessary to specify the number of servers, since different servers can work in parallel and take on different customers. Customers can wait in a buffer if all the servers are busy, so we have to define the total maximum number of clients in the system, including the clients that are being served and the waiting clients. And finally, we have to clarify the scheduling policy, or the order in which customers access servers. The most common policy being FIFO, first in, first out, meaning that customers access the servers in the order in which they arrived. In other words, first come, first served. Let's go back to the characterization of customer arrivals. The arrival process is a point process, meaning a set of points on the timeline. Each point, denoted as Ti on this graph, represents the arrival time of customer number I. The inter-arrival time denotes the time between two consecutive customers. It's denoted here as Ui, which is equal to Ti plus 1 minus Ti, and represents the interval between the arrival of customer I and the arrival of customer I plus 1. In simple models, it is assumed that the successive inter-arrival times, or U1, U2, U3, etc., are mutually independent and that they follow the same probability distribution. In this case, the customer arrival process is therefore fully characterized by the law of inter-arrival times. It's very often assumed that the law of successive inter-arrival times is an exponential distribution whose parameter is classically denoted as lambda. The probability that the inter-arrival time Ui is greater than a given threshold U is thus equal to the exponential of minus lambda U. In this case, when the inter-arrival times are independent and identically distributed according to an exponential distribution with parameter lambda, the arrival process is said to be a Poisson process of rate lambda. Lambda is called the arrival rate. It represents an average number of customer arrivals per time unit, so its unit is the inverse of the time unit, for example, customers per second. Reciprocally, the average time between two consecutive arrivals equals 1 divided by lambda and is stated in, for example, seconds.